Hello everyone, welcome back to our channel. In this video, we'll study about atomic masses. Okay, what do you mean by atomic mass? It is the mass of an atom, and along with that we have molecular mass also. What do you mean by molecular mass? It is the mass of all the atoms present in that molecule. Okay, while taking the atomic mass, we'll calculate or we'll take only the mass of a single atom, but while calculating the mass of molecular mass of a molecule, we'll take all the atomic masses of the atoms present in that molecule. So molecular mass is the sum of the all atomic masses of atoms present in that molecule. Okay, we'll see about the molecular mass later. First, let us know atomic mass. What is atomic mass? As I said, atomic mass is the mass of a single atom. Okay. Nowadays we have sophisticated techniques like mass spectrometry. By this method or by this technique, we can accurately get to know about the atomic masses as well as molecular masses. But earlier in olden days, people didn't have the methods like mass spectroscopy. But still they managed to calculate some of the atomic masses of some of the elements. How they did is, they took the reference of one element and they started calculating the masses of other elements in relative to that reference. So hydrogen being a light element, so they took the hydrogen as reference and they gave atomic mass of hydrogen as 1. They took atomic mass of hydrogen as 1 and they started calculating the atomic masses of other elements in relative to hydrogen. Okay, in earlier days hydrogen was taken as standard reference unit for measuring atomic masses, but nowadays hydrogen is no more used as reference. Nowadays we are using carbon 12 isotope, which is carbon 12 isotope is used as reference for calculating atomic masses. All other atomic masses are calculated by taking the carbon 12 isotope as standard, which is taken as standard reference. Okay, and we have one unit also to measure or to say the atomic masses. We have one unit that is called as atomic mass unit, which is abbreviated as AMU, atomic mass unit, which is the unit of atomic mass. Okay, and we have U also. U is unified mass. Unified mass. You can see both AMU and U. Both are same only. You can use AMU also, U also. Both are same. Okay. It is atomic mass unit. It is unified mass. Okay. Now, as I told, C12 or carbon isotope of carbon which is having the atomic mass 12 is taken as standard. So now C12 is the isotope of carbon, means carbon having the atomic mass 12. This is the atomic mass. Okay, this is the atomic mass of carbon. So this carbon having 12 atomic mass means this C12 isotope has 12 atomic mass units, means it is the atomic mass of this carbon. Okay, then what is the unit for one atomic mass? We can calculate it by simple mathematical steps. Okay, we'll calculate what is the mass of one atomic mass unit. Okay, we know that 12 atomic mass unit is equal to 1, I'll write 1 C12 atom. Then what will be the mass of one atomic mass unit? We don't know, so we'll get it by cross multiplication. Okay, so now 1 AMU into 1 C12 carbon atom divided by 12. So 1 AMU will be 1/12 of the C12 atom. Okay. This is what the 1 AMU we got. Now we will do the calculation. First let us know what is the mass of C12 atom. C12 atom. Okay. We know that carbon has 6 electrons, 6 neutrons and 6 protons. Okay. We will draw carbon atom here. This is the nucleus and these are the shells. So in nucleus what we have? We have 6 protons and 6 neutrons, right? And here we have 6 electrons. Now to calculate the mass, we will take only protons and neutrons. Okay, this is mass of 6 protons plus mass of 6 neutrons. Okay. And the mass of proton and neutron are almost same. So we will take it as 12 mass of protons. We have added this 6 and this 6 and we got 12 and both are taken one only, that is both are taken as protons only. So what we got? 12 mass of protons. And what is the mass of proton? That is 1.66 into 10 to the power minus 24 grams. Okay, this is the total mass of one C12 atom. Now we'll calculate what is 1 AMU. That is 12 into 1.66 into 10 to the power minus 24 grams divided by 12. Okay. What we get? These two are get cancelled, then we'll end up with 1.66 into 10 to the power minus 24 grams. This is the mass of one atomic mass unit. So 1 atomic mass unit, that is equal to 1.66 into 10 to the power minus 24 grams. Okay. This is what we calculated. Now we got to know what is the mass of one atomic mass unit. This is how the atomic masses are calculated, by taking the carbon 12 as standard reference. Okay. Now we will see about average atomic mass. You may ask me the question like, just now only we have calculated the atomic mass, then why we need this average atomic mass? We need this average atomic mass because we have a number of elements in nature and those elements are not pure in nature, means they are pure only, but along with those atoms, those elements, their isotopes also seen in nature. Like in carbon, we can see in carbon has C12, C13 and C14. These three are the isotopes of carbon. So whenever we are asked for the atomic mass of any of the element, we cannot say accurately, means if it has number of isotopes, we cannot say 12 or 13 or 14. If they specifies it as what is the atomic mass of C12, then we can say it as 12. If they ask what is the atomic mass of C14, then we can say it is 14. But when they ask generally what is the atomic mass of carbon, then we have to take the average of all those masses of those isotopes, then we'll generalize the atomic mass of that carbon by the average atomic mass. We'll take the average of those isotopes and we'll give the atomic mass of that element, like how we did for carbon. Okay, here we have calculated the average atomic mass of carbon. As I told, carbon has 3 isotopes, which are C12, C13 and C14. These are their relative abundance, means at this percentage these are abundant, means these are seen in nature, and these are their atomic masses. Atomic mass of C12 is 12 and C13 is 13.0035 and C14 is 14.00317, and this is how we calculate the average atomic mass. Here, while calculating average atomic mass, what we do, we just multiply the relative abundance with their atomic masses, and then we just sum of the 3 isotopes. For example, you can see here, this is about the C12. Here 0.98892 is the relative abundance of C12, which is multiplied to its atomic mass, that is 12, and plus about of this C13, relative abundance into atomic mass of C13, that is added to relative abundance of C14 and atomic mass of C14. So, by calculating all this, what we got lastly, that is 12.011 U. This is U, which is the unified mass. Okay, this is what we got lastly, 12.011. So, this is the average atomic mass of carbon. So, from now, if anyone asks you what is the atomic mass of carbon, then you should tell that is 12.011, not 12. Okay, 12 is the atomic mass of C12 isotope and 13 is the atomic mass of C13 isotope. So, in general, what is the atomic mass of carbon? That is 12.011. This is how we calculate the average atomic mass. Like this only we calculate the atomic masses, average atomic masses for other isotopes also. For chlorine also we will calculate like this only, and for oxygen we have number of elements which exist with their isotopes in the nature. So, this is the method how we calculate the average atomic mass. I hope you got the what you mean by atomic mass and average atomic mass. In our next video, we will see about the molecular mass. Okay, thank you.